Okay, so in example 10, we want to find the necessary minimum sample size to construct a 98% confidence interval for the population proportion with a margin of error of 0.05. First thing we're going to do, though, is assume that no prior knowledge about the population proportion is available. And in the second one, we're going to assume that prior studies suggest that the population proportion is about 0.1. Now let's notice this is different than what we did in prior examples. We're looking for a confidence interval for P instead of for mu. All right, so we're going to use this formula up here that involves proportions. Okay, so with that in mind, let's go with our 98% confidence interval. So first, just as we've done before, 1 minus 0.98 is 0.02. And if we take 0.02 and divide it by 2, it's 0.01. So we need to look up 0.01 in Excel equal norm.s.inv 0.01. And we get the z value we're going to use is 2.326. All right, so, oops, not that. So the z we're going to use is 2.326. Let's plug into our formula. We need 2.326 squared. And then, since we don't have any knowledge of p in this first one, we're going to use 0.5 for our p hat and 1 minus 0.5 for our 1 minus p hat part. All right, and notice that we don't square this, and then that is divided by the amount of error squared. So let's see, our amount of error back in our example was 0.05. So let's plug that in, 0.05 squared. And then let's stick this into our calculator. That gives us 541.0276. And remember, we always round up, so this is 542. Now, our second calculation, we're going to use exactly the same information, but we're going to assume that we know something about p. So we're assuming that p is about 0.1. So for our p hat, we're going to use 0.1. All right, so let's change our formula up just by changing p hat to 0.1. So we'll have n is 2.326 squared. That part doesn't change, but we're going to put 0.1, 1 minus 0.1, darn it, divided by 0.05 squared. And again, let's stick that into the calculator and see what we get. This time I get 194.769936, and again we're rounding up, so the actual sample size needs to be 195 people.